Hello friends, we're back. We're going to be introducing matter today and all the components of it, so get excited, get ready to rock. As you can see from the definition, matter is anything that has mass and volume. So take a look at this cute little baby penguin. Definitely has mass and volume to it, but something that people often forget is gases as well are considered matter. They take up space and they certainly have mass. In fact, air has mass to it, and so much because there's so much above us and because of gravity pushing down, it creates quite a bit of pressure, and that's where we get our atmospheric pressure from. So something that you maybe didn't know. The smallest parts of matter are basically atoms. They make up everything, and the atom for a long, long time wasn't really known. What does it look like? What are the parts? And is it really existing? But now that we have things like scanning tunneling microscopes and many more up-to-date technologies, we can actually get electronic pictures and digital images of atoms to know that, yes, all matter is made up of these tiny little particles known as atoms. So we want to look into matter, and one of the main groups of matter is pure substances. And those are broken down into either elements or compounds. So let's take a look at each of those and define them. Elements, as you know probably from the periodic table, those are the things that basically is matter that's only made up of one kind of atom. So if you took pure gold, all that gold would just be made up of tiny atoms of gold. If you take pure silver, the same thing. Only atoms of silver make up that element. And how are they actually named? If you ever looked on the periodic table, they're named for many different reasons. But if someone discovers the element, then they kind of get props to name the element. So famous people-wise, you may have heard of Einsteinium, named after Albert Einstein. For states in that, like Californium, they get props for being the state where that element was officially isolated in. For countries, you may have heard of Madame Curie and her research into radioactivity, and she found polonium and isolated it and gave props to Poland. That's why she named it polonium. And if you've heard of sodium, you may have noticed that sodium is actually the element symbol Na, which originally was natrium, and then we changed it to sodium. So Na stuck for the Latin word. As far as elements are concerned, it's pretty obvious when you look on the periodic table that all elements are either one or two letters. For example, carbon here is just one letter. The first letter definitely has to be capitalized, though. The reason for that is when we get into bonding, capital and lowercase letters will kind of determine and distinguish between what is an element and what is the next element in the compound. So all this information in that style of writing and that you can find on the periodic table. If you look at the most abundant elements on planet Earth, it's actually refreshing to see that hydrogen is number one. The awesome thing about hydrogen is that one day we might be able to use it as a fuel. If you took hydrogen gas and you burn it with oxygen, the awesome thing is that it can actually become H2O, water. So could you imagine a world where we're burning hydrogen and coming out of our exhaust pipes would be pure water? That would be amazing. You could actually drink from your exhaust pipe after a long drive. Just be careful not to burn your lips on the water. You'd want it cooled off, of course. But some would condense in the exhaust pipe, and we'd actually be purifying the world that way by driving our hydrogen cars, which would be really cool. Notice that oxygen is only 1%, obviously very important to our existence so that we can continue to breathe. But kind of an interesting list. Nothing you'll be held accountable for to know in the order, but just interesting nonetheless. The other pure substance besides element is a compound. Elements are just two or more elements that after a chemical reaction are combined together and they're in fixed proportions. So for example, water, H2O, and forgive me, that should be a lower little 2. If this is the oxygen and this is each the hydrogen, all right, it's in a fixed proportion. Now the reason compounds and elements are called pure substances is because they have their own specific properties, unlike mixtures, which we'll talk about in a little bit. If you look at the smallest unit of a compound, the one tiny individual compound, we often call that a molecule. They are made up of atoms, but the idea is since they're a compound, they're made from chemical bonds, which means they're stuck together. They're not going to be separated by just, heating it or something like that. It would need to be a chemical reaction in order to break apart that molecule. So what's really the difference in comparing elements and compounds? Well, they're both pure substances, and that just means that they each have their own specific traits, remember? But compounds, unlike elements, can still be broken down because of chemical reactions. So again, if this is your water molecule and we run electricity through it, bzzz, we can break it down into oxygen and hydrogen elements. So that you can see that a compound is originally made of those specific elements. But again, they're both pure substances because they have their own specific traits. Now, mixtures, on the other hand, are the other side of matter. So you're either mixtures or pure substances when it comes to matter. So matter is broken down into those two families. All right? Now, when we blend together things and there's no chemical reaction occurring, then we call it a mixture. For example, this delicious bowl of Chex Mix. The little pretzels and Chex Mix bites are not actually chemically combining together, they're just blended together physically. One of the two types of mixture is, it might be heterogeneous mixtures. That means that they are not uniform throughout, which means that something like a salad, you can see the individual pieces of tomato, onion, lettuce, etc. Or if you took sand and water, you see that the sand and water, though mixed up, are still separate. You can see the different pieces. You may be familiar with the term heterosexual, which just means that one sex likes the opposite sex because it's not uniform, it's different. That's maybe how you can remember it. But heterogeneous mixture, you can definitely see the different parts and pieces. A homogeneous mixture, now, on the other hand, with the prefix homo, that means of the same. So homogeneous mixtures have uniformly spread out particles, meaning that it all looks like one thing. Think about Kool-Aid, for example. There's sugar, there's red dye, there's water, there's fake flavoring, but it all looks like one liquid. So even though it's not a compound that's been chemically reacted, it still looks like one thing because it's a really well-blended mixture. Now, the prefix homo means of one, right? And we know homosexual means that the same sex likes each other. Therefore, it's of the same, kind of uniform. So you can see how those prefixes are used throughout different words. So maybe that can help you remember that homogeneous mixture would mean that everything is dissolved and uniformly spread out. Don't forget that the air that we breathe also is a homogeneous mixture. We can't see different parts. And then also, don't forget about something like tap water. Tap water is a mixture of not just water, but things like chlorine, there's magnesium in there, there's calcium, there's fluorine for our teeth. So even though it looks like one thing, there's still other parts. The only reason they look like one is because everything is dissolved. And that's what homogeneous mixtures are all about. This concludes our talking about the beginning basic steps of matter. Don't forget that elements, compounds are pure substances, and that mixtures are the other group of matter. Everything either is a pure substance or a mixture. Hopefully you can determine the difference between the two now. Have a great day. Thanks for listening.